Hello there, Edison Tech. It's MoNaCo here.
And Milks.
We're still in Unit 2 in Atomic Theory. We are getting to making some models of atoms today. We're talking about page 24, drawing Bohr models. Niels Bohr, famous physicist, truly, that helped modify the model of the atom to make it more accurate in terms of the natural phenomenon that we saw.
Rutherford student explained the problems with the planetary model that Rutherford had.
Right, the planetary model being that they couldn't explain how certain elements would emit and absorb colors of light.
Well, the planetary model was kind of, if you follow it, the orbit of the electron, if it is not losing energy, it should be emitting the light.
Right.
And then if
That's
it's
right.
not emitting light,
the problem
it should be losing energy and falling into the nucleus. And then the whole problem with this is, right, if we look at Bohr's model, it looks more like a planetary model. So
it really is.
But let's just learn how to draw them and let's
let's draw them and move on with ourselves.
Right,
Simple.
We got 4 steps today. First let's get an example. Let's do nitrogen. Is an electron configuration of 2,5 when I look it up in my periodic table.
Right, so this requires the use of a periodic table. I found N for nitrogen, 14 atomic mass, 7 atomic number, and 2-5 for electron configuration, correct?
Perfect. Yep. First step, draw a circle representing the nucleus.
Okay, so that's the thing that Rutherford discovered. Draw a circle. Got it. No problem. Easy.
Easy.
Then what do I do next is label the nucleus with the correct number of protons and neutrons. We did a lot of practice in class on this. For nitrogen, it's got 7 protons, 7 neutrons. They're not always the same, so you got to know how to do that.
Right. How did you calculate the neutrons, by the way? Because I see the
well, protons is the same as the atomic number, so that was easy. Protons equals 7. Neutrons, I'd looked at the atomic mass, which was 14, and I subtracted the atomic number from it, which was 7. So 14 minus 7 gets me 7 neutrons.
Perfect.
Got to memorize that equation.
Okay.
Neutrons.
Third step.
Third step.
I'm going to draw a circle around the nucleus for each energy level. The electron configuration shows that there's 2 because they're separated by the dash. So I have an energy level for the 2 and an energy level for the 5.
2 total energy levels because there's 2 numbers in the electron configuration sequence.
It's that simple.
2 circles, 2 numbers in the sequence. Moving on. I think the last thing we got to do is fill them up.
Put some electrons in.
Use dots to fill in the electrons for each energy level. 2 in the first, 5 in the second. The first is the inside one, as in the last video, Mr. Milks helped me really understand that.
Right.
2 electrons in the first, 1, 2 dots, and then 5 in the second ring. 1, 2, 3, 4, 5. You filled those up in a very specific way, Mr. Milks.
We're going to get into that when we get into Lewis dot diagrams, the actual rules.
Right, so it looks like you did 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, and then back again.
Yeah, it's just kind of a habit of mine. I like to start at the top, personally.
Would I be wrong if I bunched them all on one side?
Well, you wouldn't be wrong, but let's be honest. If I had some
You wouldn't be right either.
Yeah, it doesn't matter where you start. It doesn't matter if you start on the bottom or the left or the right.
But you got to spread them
A bunch
out.
of negative magnets, you put them next to each other, what would
They're
they do?
going to spread out.
They would repel. So it's best to show them spaced out evenly if you can.
Okay. So we felt like you needed a quick video, but Bohr models is essential for this unit. You got to know how to do it. Go out there and look up online the Bohr model of the atom, how to draw them. You're going to find a million different ways that are basically the same.
Right. And then we got practice.
And we got mad
practice.
practice.
Let's do it till we can't get it wrong.
Because doing it till you get it right is just setting you up for failure. You got to do it so you can't get it wrong. I get it now.
There you go.
Thanks, everybody.